Hello everyone, today we'll look into image gradient. So what exactly is it? It is a change in the image function in x or y direction. What do I mean by this? I'll explain to you in more details with these two examples. So if you see this image, we can see that the direction of the change is in both x and y direction, and it is towards the center. And the magnitude is represented from white to fading into dark. This, if you look into a bigger perspective, you can see that it is a point. Whereas in this picture, we see that the direction is in the negative x direction. And we see that the white is fading into black. If you look into bigger perspective, this is similar to be an edge. Yes, this is why we use them. Now let's look at the formula, direction and magnitude of it. As I said that it is the change in the x and y direction, we represent del f, that is a function of f, as a differential of f with respect to x direction and a differential of f with respect to y direction. Very simple, right? Now let's look at the equation for its direction. You look into this line, and to find the angle theta with respect to x direction, we see that it's simply the division of y component divided by the x component, and we take a tan inverse of it. This is something similar to that. Again, the magnitude is also similar. This line's magnitude can be represented as the square of the y component and the square of the x component, adding them up and taking a square root. So why do we need it? As I said earlier, it's usually used to find edges or corners. In this image, let's try to find out the del f function. We see that the direction of change is in x direction, that is a positive x direction, but there is no change in the y direction. So we simply put differential f by differential y equals to 0 and let the x component be the differential of function f with respect to x. Now let's look into one more example. It's something similar to what you saw, but only the direction has been changed. The y component, which was earlier 0, is now differential of f with respect to y, and the x component is now 0 because there's no change in the x direction. One more example now. So the change is in both x and y direction. So we'll simply put differential of f with respect to x and differential of f with respect to y. Let's look into one last example. How will we calculate it? The change is in both the direction, but we don't understand it. It's definitely a corner. So let's look into this in more details in the next video on Harris corner detection, which makes this even more simpler and gives us a mathematical base to detect a corner. See you in the next video. Thank you. Robometrics.